So basically, this is a question that we receive frequently. So what we typically do is for every synthetic data set that we generate is deliver a data quality report. And that includes various statistics like distributions, correlations, and multivariate distributions to really indicate the data quality where we compare the original data with the synthetic data. So I think it will be interesting to go through that and then, of course, dive into the complex analytics. So I think what we see here is the distributions. So we see it in gray, you see the original data, and in blue, you see the synthetic data. And we can actually go to the next slide to zoom in on two of these graphs. So on the left side, you see one categorical value, in this case, the churn. And there you really see that when we compare the original data with the synthetic data, that the results are really similar. So the same amount of persons in the data set that churned and didn't churn. And then to the second illustration, there we see the age, and there we also see that the lines really overlap when we compare the original data with the synthetic data. Then when we go to the correlations, we have a correlation matrix where we compare on the left side the original data and on the right side the synthetic data. Normally a correlation is between -1 and +1, but for illustrative purposes we indicated it with color intensity to really compare the patterns. And also here we see similar results. And then to the final part of our quality report, the multivariate distributions. There we combine the combination of variables and the frequency of those combinations in the data set. And even there we see similar results. So for example, on the right side, you see the combination of clients that churn in a certain segment. And even there we see that the patterns are similar. And this is basically the highlight of our data quality report. But that's of course from our side. And I think the interesting part is, of course, okay, what if we do advanced analytics on that data? And that's of course the case that we did with this use case.
Yeah. So the input data is similar to the original data.
Yeah, it's very, very similar. It's not exactly the same. Eh? It's similar. It's not the same.
Yeah. But we would assume then that the results on the original data and the synthetic data are also similar.
Comparable. Yeah. But then the question is, what about synthetic data? So the next step, we did the same. We sent that data to Syntho AI. We have the synthetic data set. We built some models, the same algorithms, the regression models, neural networks, gradient boosting, etc. And now, of course, on the original data set, still we have the .8 area under the curve. But also on the synthetic data, now we have .8 under the curve. So it's very similar, not exactly the same. In fact, it was a little bit better, but that's more or less the variability. Yeah? So the data is not exactly the same, but a little different. So it is very promising. We're very happy about this. But you would argue that, well, is this really a good test? Because, well, this is actually the test set. Eh? What I used the test set of both the original data and the synthesized data. So actually, I want to use that model on the original data. So next step, finally, I used a holdout data set.
Okay.
So there was 10% of the data I didn't send to Syntho. So I used that holdout data set to test the model on synthetic data on that original 10% original data. And then also in this case, the predictive power was preserved. We could have the same accuracy on this holdout data set. So it's really promising.
Yeah, so they can underestimate you, Edwin. You always have something in the back.
Yeah,
now,
yeah.
When I see those results, am I right to state that we don't have to worry anymore about the accuracy of our predictions when we use synthetic data?
Yes, well, I'm an analytical guy, so I never worry about analytics, of course. But,
of course.
Okay, yes, the answer to this great question. The answer is a little bit yes and no. And maybe it's good to explain with the next picture. We saw the accuracy of the models on synthetic data is similar, almost the same as on original data. It's for random forest, for regression models. In this case, for a decision tree, it was not the case because the data was too complex to create a nice decision tree. But for the other models, the more complex models, it's really the same. Indeed, we don't have to worry about the accuracy of the models on synthetic data.